You're pretty upset. Your friend is claiming that you don't know how to do physics or math because you got the prediction wrong. And you're saying that no, your prediction should be correct. The first place you want to collect data is trying to understand the velocity that your friend is driving at. Your friend said, though, they were driving at about 70 miles per hour, but it's that about that worries you. You would like to quantify that about. And every 5 minutes, you're going to record the speed that they're going at, and you're going to do this a few times. So you break out your lab manual, and you pull up the data sheet, and you write down the title of the quantity that you're going to be measuring, and you write down the units. In this case, mph is miles per hour. Your data looks something like this. The first thing you notice is that your friend is right. They are going about 70 miles per hour. They're not ever actually going 70 miles per hour at the times that you looked, but these numbers are floating roughly right around there. So from these numbers, you can calculate a couple of different things. Just what kind of things you're interested in finding out can be found in your lab manual. So you know that you're going to attempt to find the mean of that speed. And even though this equation looks a little bit complex, it's really just saying we're going to sum or add each of the terms from 1 to n. So you're just going to add up all the speeds. You're then going to divide by the number of speeds that you measured. So in this case, we're just going to add up all the speeds and then divide by the number of speeds you recorded, which was 5. We're also interested in how much these numbers vary, so not just where their average lies, but how much deviation we expect to see, how much variance. And for that, we are going to calculate this thing down here. This is the sample standard deviation. It's not quite the same as a population standard deviation because that gets into infinite measurements, and we don't have time for that. We're on a short car trip. So this that we're going to calculate here is basically asking this thing here, the mean, the x little bar over it, if I subtract some single value, I subtract that from some single value, so let's say the mean was 70, and I have 69 miles per hour. If I subtract those two, I get 1. That's how far off this thing, that one single measurement was from the mean. I then square those terms and I sum up. Once again, there's that little summation sign. I sum up all of those pieces and then divide by the degrees of freedom, or n minus 1. Square root that whole thing. This will give me my sample standard deviation. It's really a way of figuring out how much do each of these numbers here differ from my mean. So if I have a lot of numbers that are very far off the mean, I would expect to see a larger variance or a larger sample standard deviation. And if all my numbers are really close to the mean, then I should expect that sample standard deviation to shrink. In your lab manual, you'll see that if I have a normal distribution, then I would expect to see this sort of spread where this m here is my mean, and these are 1 sigma or 1 sample standard deviation away. This is 2, this is 3 away. But this is something we'll get into more. And again, you're on a short car trip. You don't have time for this. So what we want to do is we want to calculate both this mean and this sample standard deviation. So on your data sheet, you want to record your mean and you want to record your sample standard deviation. So the mean in this case is 70 miles per hour. Your friend wasn't lying. Your friend was actually being fairly accurate in saying about 70 miles per hour. The standard deviation of your friend's driving speed is 2.49 miles per hour. These two numbers are going to be pretty useful for us in figuring out just how much this affected our prediction.